So I'm going to use an iPad app called Explain Everything to go ahead and put together my Chapter 7 lectures. If you've got an opinion on it, let me know. It's got some advantages and probably some disadvantages. But this chapter we need to talk about winds. And wind in this chapter is just like the wind we've talked about in previous chapters. We're kind of building up to more and more interesting things. So wind actually is air that is relocating specifically from a high pressure to a low pressure. Okay, and I kind of think of like a box of air. It looks like a square, but a box of air with a bunch of air particles in it for my high pressure, and then a box of air with fewer air particles in it for my low pressure. And can you almost see that if I were to open kind of like a little path between these two boxes of air, can you see where my particles over here would relocate to over here? Okay, and in doing so, it would create the phenomenon we call wind. So I think we've already kind of talked about that, but keep that in mind because it's kind of a theme. Wind is an important player in weather, obviously. But in order to talk about wind, we need to kind of, we need to do a lot of things, but so one way to categorize wind is how large is it? Large scale wind or small scale wind? And can you kind of see as we're looking at those palm trees move, air is relocating from a high pressure over here to a low pressure over there, in that general direction. This is relatively small scale, but if we were to take a satellite image, let's see if I can do this, satellite image of maybe what's going on, we can see the clouds moving. And the clouds are moving as an indication of where the air is relocating or the prevailing wind. So scale is important. I'm going to skip a few. What I wanted to do. Oh, goodness. There. Now, this page isn't blank. So, scales of winds. So, what you're looking at here, we kind of talk about three different scales. The smallest scale is microscale, the medium scale is mesoscale, and the large scale is macroscale. So, I'm going to kind of give you a minute to kind of soak this in. But those small scale winds, not only are they small, but they don't last very long. So smallest winds don't last very long. Examples are, wind gusts, little dust devils, just general kind of little swirlies in the air. Those are what we call microscale winds. Mesoscale winds can last longer, hours to several minutes. They would include thunderstorms, tornadoes, and that phenomenon we've talked about before called sea breezes. Macroscale winds, now actually there are a couple of types of macroscale winds you're going to see on the next slide. But macroscale are the largest winds. They last the longest. When we've seen those cool satellite images of the hurricanes, otherwise known as tropical cyclones, those would be macroscale winds. They last long and they're relatively large. So I like this next figure. Actually, the figure's coming up, and I wanted to kind of show you. I'm going to play around with this, see if it'll. Yeah, isn't that neat? I'm going to see if I can kind of zoom, see if we like it. But anyway, so the small scale winds would be, they don't last very long, and they only go over a short period of land. Middle scale winds, mesoscale winds, tornadoes are an example of that. And then large scale winds, you basically need to use your satellite images to get a sense for them. So this was the scales of motion that I was talking about, or the figure that I was talking about. Notice that, again, we have from, let's see, I'm looking for my arrow here. There it is. We have from small scale to large scale, okay? And notice then also that we have an assortment of times. The small scale last only minutes to seconds. Then we have the mesoscale lasting hours to possibly days, and then the large scale days to weeks. So atmospheric scales of motion.